Hello, and welcome. Settle in comfortably, because tonight, we are going to dive into the greatest hunger that exists. The most ravenous black hole in the cosmos challenges everything we think we know about limits. Did you know that at this very moment, this insatiable giant is devouring the mass equivalent of an entire sun every 2 days? It lives in an ancient era, more than 12 billion light-years away, shining with such intensity that it outshines its own host galaxy. How could a structure so colossal have formed so early in the history of the universe? Tonight we will explore the physics behind this relentless appetite and the discovery that revealed this distant beacon in time. We will follow the story carried by that ancient light and imagine the lethal consequences if we were ever close to such overwhelming radiation. Before we continue, I'd like to ask for a small moment of your support. If you enjoy calm explorations of the universe like this one, consider liking the video, subscribing to the channel, and sharing it with someone who might also appreciate a quiet journey through science. Your support helps Cosmos for Rest continue bringing these peaceful stories of the universe. Now allow yourself to relax, gently close your eyes, and let science guide you. To truly understand the magnitude of the discovery that brings us together tonight, we first need to gently readjust our own perception of what it means to look up at the sky. When you lie down, relax your shoulders, and picture the celestial vault scattered with stars, you are not simply contemplating physical space. Inevitably, you are also contemplating deep time. Astronomy is the only science that is, by its very nature, a form of visual archaeology. Light, even though it is the fastest thing we know, traveling at 300,000 kilometers per second, still moves at a finite speed. It is not instantaneous. That means everything we see in the universe has already happened. Light is a messenger carrying letters from the past, traveling through the silent void, bringing images from ages long gone, from stars that may already have died, and structures that may have transformed entirely. It is precisely at this fascinating intersection between space exploration and time travel that our journey begins. With this perspective, looking not toward the present moment but toward the distant past, a dedicated team of researchers from the Australian National University, led by Dr. Christian Wolf, pointed their sensitive instruments toward the darkness of the southern hemisphere. They were not searching for nearby neighbors. Their interest did not lie in the familiar stars that form the constellations we learned to name as children. They were hunting high-energy ghosts. They were searching for quasars, the brightest objects in the cosmos, beacons that burn with such extraordinary intensity that they can be seen across distances the human mind struggles to comprehend. The search was for very specific needles of light in an almost infinite haystack of darkness, tracking signals that might reveal the secrets of the universe's childhood. The key instrument behind this discovery was the SkyMapper telescope, a tool designed not merely to observe but to map and catalog the vast southern sky with cartographic precision. SkyMapper scans the heavens, collecting data through different color filters, attempting to distinguish what might be a cool nearby star within our own Milky Way from what could be a blazing monster at the far edge of the observable universe. And during one of these meticulous scans, while analyzing terabytes of digital data, a particular signal caught the astronomer's attention. It was a point of light that at first glance might have seemed trivial, but its spectral signature told a completely different and astonishing story. The object received the technical designation J2172802. It may sound like a cold name, merely a sequence of coordinates in a stellar catalog, yet those numbers concealed the secret of one of the greatest mysteries ever encountered in modern astrophysics. When the team analyzed the light arriving from that point, cross-referencing data with the Gaia Space Observatory from the European Space Agency and the WISE satellite from NASA, they realized they were not looking at an ordinary star. They were looking at a supermassive black hole. But not just any black hole. The light striking the sensors in Australia had begun its journey more than 12 billion years ago. Let's pause for a moment and try to internalize what 12 billion years truly means. When the photons that make up the image of this object left their origin, our solar system did not exist. The sun did not exist. The Earth was nothing more than scattered dust inside clouds of gas that had not yet collapsed. That light traveled through the void while our galaxy was forming, while the first planets cooled, while life emerged in Earth's primitive oceans, while continents drifted and collided. And while humanity took its first uncertain steps through history, during every moment of joy and sorrow in our species' existence, that light was already on its silent journey through the vacuum, crossing the vast intergalactic abyss, steady and patient, until finally ending its odyssey inside the mirrors of a telescope we built ourselves. What that light revealed was a portrait of the primordial universe, a time when the cosmos had less than 10% of its current age. We are talking about a period often called the infancy of the universe, shortly after the cosmic dark ages, when the first lights were igniting and beginning to reionize the neutral gas that filled space. In theory, during this early era, cosmic structures should mostly have been smaller and still forming. Galaxies should have been proto-galaxies, messy clusters of gas and young stars trying to settle into balance. Yet J2157 defied that expectation in a dramatic way. There it was, a fully grown supermassive black hole with an unimaginable mass already installed at the heart of that young universe like a premature king. The discovery sent an immediate shock through the scientific community. It was like discovering a perfectly built modern metropolis standing among the ruins of an ancient civilization. How could something so enormous form so quickly? Physics, as we understand it, imposes speed limits on growth. A black hole grows by swallowing matter, but that process releases energy that pushes surrounding matter away, creating a natural balance known as the Eddington limit, which should restrict how fast a black hole can grow. Yet J2157 seemed to have ignored every cosmic speed limit sign. It had grown with a ferocity that theoretical models struggled to explain, suggesting that in the early universe the rules of the game may have been played with far greater violence. Confirming the distance and nature of this object required collaboration across multiple datasets and careful spectroscopic analysis. The key measurement is called redshift, the tool astronomers use to measure these enormous distances. Because the universe is expanding, the space between us and J2157 stretched during the journey of its light. The light waves themselves were stretched as well, shifting toward the red end of the visible spectrum. The greater the shift, the farther away the object, and the older the image we see. The measured value made it unmistakably clear. We were peering into the deep past, observing a time when the universe was far denser, hotter, and more chaotic than the calm night sky we see today. Yet what truly allowed us to detect this object across such unimaginable distance was not the black hole itself, because as we know, a black hole's gravity traps even light, making it invisible, but the feast taking place around it. J2157 was discovered because it powers an extraordinarily luminous quasar. It shines with the combined brightness of thousands of normal galaxies. Without that extreme brilliance, without that cosmic gluttony that converts matter into light, it would remain hidden in the shadows of the past, forever undetectable. It announced itself across time through the furious glow of its constant feeding. The discovery of this particular giant raised fundamental questions about the seeds of black holes. To reach such enormous size so soon after the Big Bang, J2157 could not have started small. It could not have been born from the collapse of a typical star like the stellar black holes scattered across the Milky Way. Scientists began speculating that monsters like this must have formed from heavy seeds, perhaps gigantic clouds of gas collapsing directly into black holes under their own gravity without ever becoming stars. Or perhaps from population 3 stars, hypothetical colossal stars composed only of pure hydrogen and helium. The work led by Dr. Wolf and his team was not simply about locating a point in the sky. It was about rewriting a chapter of the universe's biography. Every photon captured by SkyMapper helped paint the portrait of a giant, dominating its environment, while the universe itself was still learning how to build complex structures. The existence of J2157 is proof that the early cosmos was a place of extremes, where violent and rapid processes shaped the architecture of future galaxies. When we examine the data, we see more than numbers and graphs on a computer screen. We see the persistence of matter and energy. We see gravity working as the great sculptor of reality, pulling, compressing, and igniting the universe in an eternal dance. Detecting an object 12 billion light-years away is a triumph of human curiosity and technology. We have built eyes of glass and metal capable of capturing whispers of light emitted before Earth even existed, and minds capable of understanding what those whispers mean within the context of eternity. This discovery invites a deep and calming sense of humility. Faced with such immense scales of time and distance, our immediate worries dissolve into the vastness. We are invited to float within the current of deep time, safe observers of a drama that happened long, long ago. J2157 sits there in our star maps like a monument to hunger and grandeur, patiently waiting for us to uncover its presence. And now that we have found it, it becomes the perfect starting point for tonight's journey. This story is not only about a black hole, it is about the history of light, the history of time, and the story of how the universe became the vast and wondrous place that shelters us while we sleep. Now that we have placed ourselves in time and space, we can move a little closer, carefully through imagination, to the central mechanism of this story. The title of The Most Ravenous Black Hole is not poetic exaggeration. It is a literal description based on precise physical measurements. But how exactly does an object swallow the mass of an entire sun every 48 hours? To understand that, we must picture celestial mechanics operating on scales of violence and grandeur far beyond anything we experience here on Earth. This is not a mouth opening in empty space. It is a complex and structured gravitational vortex. At the heart of this process lies what astrophysicists call an accretion disk. Imagine a carousel of incandescent gas, a vast spiral of matter rotating around a central point of absolute darkness. In the young universe where J2157 resides, space within and between galaxies was rich with gas. Hydrogen and helium were abundant, the primordial fuel. When these enormous clouds of matter approach the gravitational influence of a black hole, they do not fall straight inward. The universe is governed by angular momentum, which means almost everything in space is spinning. As the gas is pulled toward the abyss, it begins to orbit the black hole, forming a vast flat disk, somewhat like the rings of Saturn, but millions of times larger and infinitely more energetic. This disk is the black hole's dinner plate. The matter within it is not still. It races around at astonishing speeds, significant fractions of the speed of light, spinning faster and faster as it approaches the center. And here physics enters with tremendous force: friction. In the vacuum of space, we often imagine there is no friction, but inside such a dense accretion disk, the layers of gas are packed closely enough that they rub violently against one another. The inner layers rotate faster than the outer layers, creating intense shear turbulence. That friction converts kinetic energy into heat. The gas grows hotter, and this is no gentle warming. Temperatures rise to millions of degrees Celsius, transforming the matter into plasma, the fourth state of matter, where electrons are stripped away from atomic nuclei. Inside this whirling, superheated cauldron, the meal is prepared. Gravity pulls inward, friction heats the gas, and the matter loses angular momentum, slowly spiraling closer and closer until it crosses the event horizon. The event horizon is the point of no return, the mathematical boundary beyond which not even light can escape the gravitational pull. Once gas crosses that line, it vanishes from our observable universe, adding its mass to the total mass of the black hole. That is the moment we say the black hole has eaten. J2157 consumes roughly 1 solar mass every 2 days. Picture our sun, a massive sphere of plasma more than 1 million kilometers across, weighing more than 300,000 Earths. Now imagine all that mass being torn apart, stretched like spaghetti by tidal forces, and swallowed within 48 hours. It is a continuous flow, a torrent of matter pouring down a cosmic drain. This feeding rate is what allowed the black hole to grow so rapidly. It gains about 1% of its mass every million years. That sounds small on human timescales, but on the exponential scale of black holes, it is explosive growth. This feeding process is extraordinarily efficient in terms of energy. Nuclear fusion inside stars like our sun converts only a tiny fraction of mass into energy. But matter falling into a black hole is the most efficient energy-generating process known in the universe. Between 10 and 40% of the infalling mass can be converted directly into radiation before disappearing. That is why, paradoxically, the region around a black hole is the brightest place in existence. The hole itself is dark, but its meal shines like 1,000 dying suns before vanishing. The mechanics of this hunger also involve powerful magnetic fields. The rotating plasma generates magnetism, and those magnetic field lines can twist and snap, launching jets of particles outward from the disk, perpendicular to its rotation. These jets travel near the speed of light, drilling through intergalactic space for thousands of light years. While our focus here is on the ingestion of matter, it is important to remember that a black hole is a complex engine. It swallows immense quantities of material, yet it also throws energy and particles back into the universe, stirring everything around it. What makes J2157 unique is the sustainability of its feast. Many black holes experience cycles of feeding and quiet, but to reach such enormous size so early in cosmic history, this one must have maintained its frenzied pace for a long time. It lived inside a cosmic buffet where matter never stopped arriving. That tells us something profound about the density of the early universe. It was a place where collisions were common, where streams of cold gas constantly fed galaxies, allowing gravitational monsters to grow without restraint. Contemplating this mechanism inspires quiet admiration. We are witnessing the fundamental forces of nature, gravity, electromagnetism, thermodynamics, operating at their most extreme limits. There is nothing more intense than this. And yet from a distance, through the lens of science and the safety of separation, there is a strange elegance within the chaos. It is matter fulfilling its gravitational destiny. It is the universe organizing itself, concentrating mass into singular points and clearing the surrounding space. The hunger of J2157 is not malicious. It is natural. It is the ultimate expression of Newton's law of gravity and Einstein's curvature of space-time. It is an engine transforming the chaos of diffuse gas into compact gravitational order. And as we imagine this accretion disk spinning, glowing, feeding the giant, we can almost feel a hypnotic rhythm. The constant rotation, the eternal cycle of matter and energy, the slow and powerful pulse of a giant feeding in darkness. This image helps us relax because it places everything into perspective. Our daily worries, our hurried lives, our concerns, all seem small beside a process capable of consuming entire stars. The universe moves according to its own rhythm, slow, vast, and inevitable. J2157 remains there, or remained there in that distant past, spinning in solitary majesty, a reminder that nature is powerful and immense beyond comprehension, and we, small observers, have the privilege of understanding this mechanism without ever approaching it. We can simply close our eyes and picture the great cosmic carousel slowly turning in the theater of our minds, gently rocking us into deep, dreamless sleep, protected by the vastness of space that separates us from that eternal hunger. Following the trail of energy released by this cosmic banquet, we arrive at one of the most astonishing phenomena associated with J2157, its luminosity. We have already mentioned that it shines, but the word shine is far too modest to capture the true scale of what is happening. What we are dealing with is an intensity of light that pushes the limits of our imagination. This object is classified as a quasar, short for quasi-stellar radio source, a term dating back to the time when astronomers were not entirely sure what these brilliant points in the sky really were. Today we understand them as the active cores of young galaxies, powered by supermassive black holes. And J2157 is one of the most luminous ever discovered. If we could perform an impossible experiment and place this black hole at the center of our own galaxy, the Milky Way, night on Earth would never be the same again. Its glow would be so intense that it would appear in our sky 10 times brighter than the full moon. Imagine that for a moment. A single point of light concentrated like a star, yet powerful enough to illuminate the entire planet, casting clear, sharp shadows across the ground during the quiet hours of the night. The other stars, the ones we love to gaze at, would disappear completely from our view, washed out by that single cosmic beacon. The sky would be ruled by one sovereign light. The radiation emitted by it is anything but gentle. It is the luminous cry of matter being torn apart. The accretion disk radiates across the entire electromagnetic spectrum: radio waves, visible light, ultraviolet radiation, X-rays, and gamma rays. It is a symphony of energy playing across the universe. And yet, it is precisely this intense light that allows us to study the object. J2157 functions like one of the most powerful lighthouses in the observable cosmos. Its light travels for billions of years through the vast intergalactic darkness, acting like a probe that illuminates everything along its path. As the photons from this quasar journey toward Earth, they pass through invisible clouds of gas, through the halos of distant galaxies, and across the immense cosmic web that binds the universe together. Each time the light crosses one of these clouds, a small portion of it is absorbed by the atoms of gas within it, leaving dark marks in the spectrum. almost like the lines of a barcode. By reading this barcode here on Earth, astronomers can map the chemical composition of the early universe. Without the fierce brilliance of J2157, much of the cosmos between us and that distant point would remain completely hidden in darkness. In a sense, it illuminates the invisible structure of reality. This extraordinary brightness also reveals something about the temperature of the accretion disk itself. To emit so much ultraviolet radiation, the matter spiraling around the black hole must be heated to millions of degrees. It becomes a cosmic furnace burning with the power of 1,000 trillion suns. Try to picture that number, 1,000 trillion. That is more energy released in a single second than our sun will emit throughout its entire 10 billion year lifetime. And this release of energy is not a brief flash. It is continuous, sustained by the steady consumption of a solar mass every 2 days. There is a poetic paradox hidden here. The darkest object in the universe, a black hole from which nothing escapes, is responsible for creating one of the brightest phenomena known. Absolute darkness at the center becomes the cause of overwhelming light around it. It is a dance of opposites. Gravity, which we usually associate with pulling things inward and hiding them away, here becomes the engine that drives light outward, announcing its presence across the abyss of time. Scientists also use this light to study an important chapter of cosmic history known as the era of reionization. When the universe was very young, it was filled with a fog of neutral hydrogen gas that blocked light from traveling freely. The first stars and the first quasars emitted enough energetic ultraviolet radiation to break apart those hydrogen atoms, ionizing them and gradually clearing the cosmic fog. J2157 was one of the great torches of that process, helping to make the universe transparent. It was not only a hungry monster, it was also one of the architects of the clarity we observe in the cosmos today. Observing its brilliance is like looking at an ancient torch lit near the beginning of time, a flame whose light is only now reaching us. The photons arriving at our telescopes today are old, stretched and weary from traveling 12 billion years across expanding space, but they still carry the essential information of that violent moment in cosmic history. They tell us that the young universe was not a quiet place. It was vibrant, energetic, and filled with extraordinary light. For us, seeking rest and calm, that distant glow can become something else entirely. In our imagination, we can see it not as a threat, but as a quiet lantern burning somewhere in the depths of space, a small point of reference in an immense ocean of darkness. Knowing that it existed, shining with such persistence, gives a sense of continuity. The universe is not an empty void. It is a stage filled with energy, transformation, and light. The glow of J2157 reminds us that beauty can emerge from the most extreme circumstances. The destruction of gas and stars becomes the beacon that allows us to see the ancient universe. It is a cycle of revelation and transformation, and as we prepare to rest, we can picture that light continuing its long journey through space, passing silently between galaxies, gliding past distant nebulae, until it gently reaches our instruments and our understanding, carrying with it the quiet message that even in the deepest darkness, light always finds a way to travel. Numbers on an astronomical scale can quickly become abstract. Words like billions and trillions can lose their weight when repeated too often. To truly feel the physical scale and majesty of J2157, we need a familiar ruler for comparison. And for that, we can look toward the center of our own galactic home, the Milky Way. There, about 26,000 light-years away from Earth, lies Sagittarius A, the supermassive black hole at the center of our galaxy. It is the gravitational anchor around which the entire Milky Way rotates, including our own sun. Sagittarius A is immense by human standards, containing the mass of about 4 million suns. 4 million suns. Even that number already seems staggering. Our local black hole is a respectable cosmic giant, but when we place Sagittarius A beside J2157, the comparison becomes almost comical in its imbalance. Our galactic giant would appear little more than a grain of sand next to an enormous mountain. J2157 is estimated to contain roughly 34 billion times the mass of our sun. Let's pause again and absorb that number. 34 billion compared to 4 million. J2157 is more than 8,000 times more massive than the black hole at the center of the Milky Way. If Sagittarius A were the size of a person, J2157 would be a mountain as large as Mount Everest. The scale difference is so dramatic that astrophysicists often use a different label. It is not merely supermassive, it is ultramassive. Now consider its physical size. A black hole is defined by its event horizon, the spherical boundary beyond which nothing can escape. The diameter of this horizon increases directly with the mass of the black hole. Sagittarius A, and, despite its impressive weight, is relatively compact. Its event horizon would comfortably fit inside the orbit of Mercury, the closest planet to the Sun. But J2157 belongs to an entirely different category of cosmic beast. If the center of J2157 were placed where our Sun currently sits, its event horizon would swallow Mercury, Venus, Earth, and Mars. It would engulf the asteroid belt, Jupiter, Saturn, Uranus, and Neptune, and it would keep going. Pluto and the entire Kuiper belt would vanish inside that darkness as well. The diameter of this black hole is hundreds of times larger than the distance between Earth and the Sun. It is an abyss the size of an entire solar system. Imagine a sphere of absolute darkness filling all the space where every planet we know now orbits. Inside it there would be nothing but the central singularity and gravity beyond imagination. This comparison can create a feeling of cosmic vertigo, but also a sense of relief. Knowing that structures of such enormous magnitude exist makes our small planetary existence feel both fragile and precious. Yet it also reminds us that we live in a very quiet neighborhood of the universe. Our own black hole is a calm giant, almost on a diet, occasionally snacking on stray gas or an unlucky asteroid. J2157, in contrast, is a relic from an era of titans, a time when cosmic monsters grew without restraint. Its mass is so vast that its gravitational influence stretches across enormous regions of its host galaxy. While Sagittarius A dominates only the immediate galactic center, J2157 would rule its entire domain. Its gravity would act as the anchor holding its young galaxy together, but also as the force threatening to consume it from the inside. Visualizing this difference in scale reveals the diversity of the cosmic zoo. Not all black holes are alike. Some are small remnants of dying stars. Others are colossal entities that seem almost to challenge the limits of formation itself. J2157 is an example of what nature can build when it has two limitless resources at its disposal: time and matter. Reflecting on this invites a quiet sense of reverence. The universe does not hold back when it comes to grandeur. It constructs cathedrals of gravity that last for billions of years, and we, with our curious minds, are capable of measuring those structures without ever leaving our small blue world. This ability to comprehend the vast, to measure the seemingly immeasurable, is what connects us to these cosmic giants. We may be small in physical scale, but our imagination is immense, and within that safe imagination, guided by science, we can rest comfortably knowing that the monster of 34 billion suns is unimaginably far away, locked deep in the past of the universe, while we sleep peacefully under the gentle gravity of Earth. All of this energy, all of this mass being consumed and transformed into light, comes with a cost for the surrounding environment. J2157 is not simply a silent consumer growing quietly in the darkness. It is an active and violent engine that shapes and often devastates its surroundings through radiation and powerful winds. Physics teaches us that every action has a reaction, and when the action involves an ultramassive black hole, the reaction can be cataclysmic. As matter falls toward the black hole and heats up in the accretion disk, it emits torrents of high-energy radiation. Powerful X-rays and intense ultraviolet light erupt outward, flooding the surrounding galaxy. Light itself carries momentum, and that momentum exerts pressure. The radiation becomes so powerful that it acts like a physical wind pushing matter away. Imagine a hurricane, but made of light and subatomic particles. These quasar winds blast outward from the galactic center with incredible violence, reaching speeds of thousands of kilometers per second. As they sweep through space, they scatter the interstellar gas and dust they encounter. In a strange act of cosmic self-regulation, the black hole feeds so aggressively that the energy released by its feast begins to blow the remaining food away. This has profound consequences for the galaxy around it. Cold gas is the raw material from which new stars are born. Stars form inside calm, dense clouds of gas known as nebulae, but the powerful winds from J2157 heat and disperse that gas. In effect, they sterilize the galaxy. By pushing the gas into intergalactic space, the black hole shuts down the formation of future stars. Over time, the galaxy may become a quiet graveyard of aging stars, brilliant suns that will slowly fade without leaving behind new generations. The radiation also creates a lethal zone around the galactic center. The intensity of the X-rays and ultraviolet radiation strips electrons from atoms and shatters complex molecules. The chemistry required for life would be impossible within thousands of light-years of the quasar. Any rocky planets in that region would have their surfaces scorched by relentless radiation, their atmospheres stripped away, their oceans evaporated. This dramatic interaction reveals the intimate connection between a galaxy and the black hole at its core. They evolved together. The growth of the black hole can determine the destiny of the entire galaxy. It is a relationship of cosmic coevolution, where the predator at the center influences the health of the entire galactic body. J2157, with its extraordinary appetite, may have been one of the most efficient galaxy-altering engines ever to exist. Its growth may have come at the expense of the future stars that might otherwise have formed within its home. Yet even here, there is a certain cold beauty in the physics. What we perceive as destruction is also transformation. The gas expelled by the quasar winds does not disappear. Instead, it enriches the intergalactic medium with heavy elements forged inside ancient stars. In this way, the black hole spreads cosmic material across vast distances, influencing the evolution of the universe far beyond its own galaxy. Understanding these effects helps us see the cosmos not as a collection of isolated objects, but as a vast, interconnected ecosystem. Events taking place in the dark heart of a galaxy can shape the birth of stars in regions thousands of light-years away. Gravity and radiation weave together an intricate web of cause and effect, and J2157, with its extraordinary power, becomes a perfect laboratory for studying those connections. For us here on Earth, this knowledge also brings a sense of quiet gratitude. We live in a galaxy where the central black hole is calm, where the cosmic winds are gentle, and where gas clouds can slowly collapse to form stars like our Sun and planets like our Earth. The violence of J2157 may be necessary somewhere in the cosmic balance, but it is a violence we are fortunate to observe only from afar. Seen from a safe distance, it becomes like a distant fire burning on the horizon of the universe. Powerful, transformative, and strangely beautiful. While here, under our quiet night sky, we can rest peacefully. To truly appreciate the privilege of our cosmic safety, let us perform a bold exercise of imagination. For a moment, only within the quiet theater of the mind, let us bring J2157 closer and place it where our own Sagittarius A currently resides, at the center of the Milky Way, 26,000 light-years from Earth. Suppose our calm galactic neighbor were replaced by this ravenous titan. What would our reality look like? What would the night sky become? The first and most immediate change would be the disappearance of true darkness at night. The glow from the accretion disk of J2157 is so immense that even across such a vast distance it would dominate our sky. It would not appear as a tiny point. It would shine like a strange new star, 10 times brighter than the full moon. But it would not be the gentle silver glow of moonlight we know. Instead, it would be a harsh blue-white brilliance, piercing and intense. Shadows would stretch across the ground even in the middle of the night. The constellations would fade from view. The soft river of stars we call the Milky Way would vanish, drowned beneath the glare of this single celestial beacon. In effect, we would live under two suns, our familiar sun during the day and the eye of the quasar during the night. The idea of a dark night would disappear entirely. Nocturnal animals would struggle to adapt. The delicate circadian rhythms that govern life on Earth would be thrown into confusion. Yet the visual change would be the least of our worries. The true danger would arrive invisibly. Along with visible light, J2157 would bombard our solar system with torrents of high-energy radiation, X-rays and gamma rays. Even from 26,000 light-years away, the intensity would remain significant. The heliosphere of our Sun, the protective magnetic bubble surrounding the solar system, would be compressed by this incoming radiation. Earth's atmosphere would endure a relentless assault. Our ozone layer, which shields the planet from ultraviolet radiation, would gradually erode under the constant exposure to ionizing energy streaming from the galactic center. Without that protective layer, ultraviolet radiation from our own Sun, combined with that from the quasar, would sterilize the surface of the planet. Complex life on land would struggle to survive. The deep oceans might offer some refuge, but ecosystems on the surface would collapse. The sky itself would no longer feel like a quiet source of wonder. It would become a constant reminder of cosmic danger. Radiation could also alter the chemistry of the atmosphere, forming harmful compounds and changing the climate in unpredictable ways. Meanwhile, the energetic winds from the quasar might disturb distant regions of our solar system. The Oort cloud and the Kuiper belt, vast reservoirs of icy bodies at the outer edges of our system, could be destabilized, sending comets and asteroids inward. The risk of impacts on Earth could increase dramatically. Even the broader structure of the Milky Way might change under the influence of such a powerful engine. Gas within the galaxy could be pushed outward, disrupting the graceful spiral arms and preventing new generations of stars from forming. The galaxy we know might gradually lose its ability to create the stellar nurseries that once gave birth to our sun. This imagined scenario, unsettling as it may sound, ultimately brings us a surprising sense of calm. By picturing what could have been, we begin to appreciate what is. Our cosmic address is remarkably fortunate. We orbit far enough from the galactic center to avoid dangerous radiation and crowded stellar environments, yet close enough to benefit from a galaxy enriched with the heavy elements needed for planets and life. Our central black hole is quiet. Sagittarius A is a sleeping giant. It does not blaze like a quasar. It allows gas clouds to drift peacefully, stars to form slowly, and planetary systems like our own to evolve undisturbed. J2157, by contrast, is a wonder best observed from a distance across space and time. It is like a volcano erupting on a distant horizon, magnificent to watch yet deadly to approach. The reason we can admire it calmly is because it lies 12 billion light-years away and 12 billion years in the past. And so we return to our real night sky, the dark sky above Earth scattered with soft starlight. The darkness itself is a gift. The silence of space is a form of protection. The quiet normality of our galaxy is, in truth, one of the greatest cosmic blessings. With that awareness, it becomes easier to relax. The tension of the day fades. Our place in the universe is safe and stable. The great monsters of gravity exist far away in distant eras, while here the stars shine gently and the night remains calm. One of the most intriguing challenges for the scientists who study J2157 is trying to see beyond its overwhelming brilliance. Imagine attempting to observe the delicate wings of a tiny firefly flying only millimeters away from a stadium floodlight shining at full intensity. The firefly represents the galaxy hosting the black hole. The floodlight represents the quasar itself. The glow from the accretion disk is so powerful that it drowns out the light of every star in the surrounding galaxy. Billions of suns may be shining there, yet their collective light becomes almost invisible beneath the blinding radiance of the quasar. This creates one of astronomy's great mysteries. We know an extraordinary amount about the black hole itself, its mass, its feeding rate, the temperature of its disk, but we know very little about the galaxy that surrounds it. The host galaxy is hidden behind the brilliance of its own monster. Astronomers believe that in order to feed such a massive black hole, the galaxy itself must be enormous. It likely contains vast reservoirs of gas and may have formed through the mergers of several smaller proto-galaxies early in cosmic history. But observing those structures directly is extremely difficult because the quasar's light overwhelms everything else. This strange imbalance teaches us something profound about light in the universe. Normally, we think of stars as the ultimate sources of cosmic illumination. Yet when gravity reaches the extreme conditions found near a black hole, it can extract far more energy from matter than the peaceful nuclear fusion inside stars. The destroyer becomes brighter than the creators. The black hole, which consumes matter, becomes the most luminous object in existence, while the galaxy that produces stars hides quietly behind it. To overcome this challenge, astronomers use sophisticated techniques. They attempt to digitally subtract the quasar's light from images, creating a kind of artificial eclipse within the data. By removing the overwhelming brightness, they hope to glimpse the faint glow of the galaxy behind it. With new observatories such as the James Webb Space Telescope, scientists are hopeful that future observations will finally reveal that hidden galactic home. They want to see the scars carved into the galaxy by the black hole's enormous energy. They want to know whether new stars are still forming there, or whether the powerful winds of the quasar have already extinguished the galaxy's ability to create new suns. For now, however, J2157 dominates the scene entirely. It stands alone like a cosmic soloist on a vast stage, singing so loudly that the orchestra behind it becomes inaudible. A single object only the size of a solar system outshines an entire galaxy, stretching across 100,000 light-years. It is a remarkable demonstration of concentrated gravity overpowering the gentle light of billions of stars. And yet this hidden galaxy adds a quiet layer of wonder to the story. The universe still keeps secrets, not hidden by darkness, but hidden by too much light. In a sense, J2157 protects its galactic home with a shield of photons, revealing its hunger while concealing its birthplace. Contemplating that hidden world reminds us that even our most advanced instruments have limits. Some things exist beyond our ability to see clearly. For now, entire galaxies may lie concealed behind the brilliance of a single cosmic engine, and accepting that mystery can feel surprisingly peaceful. We do not need every answer immediately. It is enough to know that somewhere beyond that blaze of light, billions of unseen stars may be quietly orbiting their powerful master. We can imagine them there, stars rising and setting across alien skies, planets perhaps circling in the distant outer reaches, all bathed in the constant glow of the quasar at the center. The universe is vast enough to hold mysteries for billions of years, and we can simply observe, appreciate the brilliance, and allow our imagination to gently explore what science has not yet fully revealed. As that thought settles softly in the mind, the cosmos becomes less like a puzzle to solve and more like a quiet ocean to drift upon, an ocean of light, gravity, and time, guiding our thoughts calmly toward rest. Everything in the universe, even the most voracious monsters and the brightest lights, is ultimately subject to the quiet and unstoppable passage of time. The banquet of J2157, as eternal as it may seem in our story tonight, will not last forever. In fact, because we are looking so far into the past, it is very likely that in the present moment of that distant galaxy, the feast has already ended. At some point, the supply of gas runs out. The galaxy becomes gradually emptied of the cold fuel that once flowed toward the center. The brilliant accretion disk that now shines with furious energy slowly begins to thin, to cool, and to fade. The dazzling light that once rivaled the brightness of countless galaxies will dim. First it will redden, then soften into faint infrared whispers until eventually the glow disappears entirely into darkness. The giant will fall into deep hibernation. The black hole itself will remain, still carrying its colossal mass of 34 billion suns, but it will become invisible, silent, a gravitational ghost resting at the heart of its galaxy, waiting patiently for the distant future when an unlucky star might wander too close. In that quiet state, it will resemble our own Sagittarius A, a sleeping king remembering its ancient days of glory. What makes our observation so special is timing. Through a remarkable cosmic coincidence, we happen to exist at the exact moment when the light from its era of furious activity has finally reached us. We are witnessing a brief episode in the life of a titan, frozen in a frame of light that traveled for 12 billion years before arriving at our telescopes. It reminds us that the universe is not a static painting. It is a flowing story, a vast river of change. Galaxies are born, stars ignite, black holes feed and fall silent. The sky above us is not fixed. It is a film unfolding at an incredibly slow pace. When we think about J2157 as we prepare for sleep, there is no need to feel fear about its immense hunger. Instead, we can feel a calm admiration for the scale of the reality we inhabit. The atoms inside our bodies were forged in ancient stars. The gravity that shapes black holes is the same force that gently holds our feet to the earth. We are part of the same universe that creates these giants. And here, on our quiet blue planet, protected by distance and deep time, we can close our eyes and let that vast image carry us gently toward rest. The storms of the cosmos, the collisions, the blazing disks of plasma, the roaring winds of radiation, are part of the great transformation that keeps the universe alive. Energy is spent, matter is rearranged, light is released and sent traveling across unimaginable distances. In the end, everything gradually moves toward stillness. Just as the furious banquet of J2157 will one day fade into silence, our own day now reaches its calm conclusion. Imagine yourself floating safely in the quiet vacuum of space, far from the heat and turbulence, simply watching that distant point of light as if it were a personal night star. The universe around you is vast and peaceful, Galaxies drift slowly through the darkness. Gravity keeps every world in its gentle orbit. Everything is exactly where it should be. Allow the immense numbers we explored tonight, 12 billion years, 34 billion suns, to softly press down on your smaller concerns. Let them dissolve into the immense scale of the cosmos. Feel the weight of your body resting comfortably on the bed, just as the gravity of Earth holds you securely. The same universal force that shapes galaxies now quietly supports you. If this quiet journey through the depths of space brought you a moment of calm, consider supporting the channel by liking the video and subscribing to Cosmos for Rest. There are many more stories written in the stars waiting to be explored together. Now take a slow breath in and gently let it out. Let it sleep well. And until our next journey through Cosmos for Rest,